PV inverters connection Modbus TCP Ethernet. In this video, we will cover how to connect the e-power control to the PV inverters via a wired network connection, Ethernet. This video is divided into 5 sections. Required materials: connecting the PV inverter to the controller, configuring the LAN port, adding the PV inverter to eConf, testing the communication with the PV inverter. Part 1. Required materials. Elum's device and the PV inverters are communicating in Modbus TCP. For this, we will need Elum's device, RJ45 to RJ45 Ethernet cable with a total length less than 100 meters, a switch required if connecting multiple devices to the Elum device, or if the device is connected to Internet via a wired connection. Laptop, RJ45 to RJ45 Ethernet cable for configuration purposes, USB to RJ45 adapter if your laptop does not have a LAN port. Part 2. Connecting the PV inverter to the controller. Before connecting the PV inverter to e-power control, make sure to place all devices in the same subnetwork as the Elum device, avoiding 192.168.4, which is reserved for LAN port 4. Set each device's subnet mask to 255.255.255.0 and enable dynamic power control. Start by connecting one end of the RJ45 to RJ45 cable to any of Elum's LAN ports, 1, 2, or 3. The LAN port 4 is reserved for configuration only. Next, connect the other end of the RJ45 to RJ45 cable to the switch. With the e-power control connected to the switch via the LAN port, plug the RJ45 cable from the PV inverter into the switch. When properly connected, the LED should start blinking, indicating a valid connection. So to recap, we've established a wired connection to the switch, which is connected to the e-power control via LAN port 1, 2, or 3. Please note that it's highly recommended to use a surge protection to avoid any issues on the communication ports. Part 3. Configuring the LAN port. Connect your laptop to the LAN port 4 of Elum's device. When properly connected, the LED should start blinking, indicating a valid connection. Access the settings from your laptop. Go to Network and Internet Settings. Go to Change Adapter Settings. Right-click on Connection to the local network. Select Properties. Click on Internet Protocol version 4, TCP/IPv4. Select Properties. Select Obtain an IP address automatically to enable automatic IP address allocation. Or select Use the following IP address for manual IP address assignment and enter the settings as shown in the next window. A small TCP/IP window will appear. Click on Yes. Then click on OK to save configuration. Open your preferred browser and log into eConf by entering the following IP address: 192.168.4.127. Enter your password to log into eConf and click Sign In to connect. On the left sidebar, click on Network. Click on Configure a new connection. Then, in the interface menu, choose Wired Access LAN 1. Select DHCP for automatic IP address allocation. Alternatively, choose IP Static to manually enter the IP address and network settings, mask, gateway, DNS. For now, we will use DHCP configuration for automatic address allocation. Click OK to save the configuration. Your wired connection is now configured. Part 4. Adding the PV inverter to eConf. In the column specific to the LAN 1 connection, click on Add Device. Enter the device name. Select the PV inverter's vendor from the drop-down list. Select the reference of the PV inverter from the vendor-specific drop-down list. Select the Modbus TCP protocol for communication between Elum's device and the PV inverter. Enter the IP address of the PV inverter. Configure the port, slave ID, response timeout, and byte timeout. Additionally, enable these two options if multiple devices are connected on the same daisy chain. Click on OK to save the settings. Part 5. Testing the communication with the PV inverter. To test the connection between Elm's device and the PV inverter, first check the communication status by clicking on the three dots next to the name of the PV inverter you added. Click on Test. If your PV inverter is not connected, this window will appear with the Not Connected red indicator. Follow the provided troubleshooting instructions to help resolve the communication issues. Another way to test all devices connected to the same port in a daisy chain is by clicking the refresh icon next to the configured port LAN 1. This will display the status of those devices, and you can expand the window by clicking on the device name. eConf provides a few troubleshooting instructions to help resolve communication issues. Once all these steps are completed, communication should be established. As a second step of connection testing, let's verify the data acquisition. Navigate to All Devices from the left sidebar. Click on the recently added PV inverter. The page displays all the data that the controller will read from the PV inverter. Cross-check all the read values with those displayed on the PV inverter itself, if applicable. The controller must receive accurate data to prevent issues in control scenarios and set points. Please feel free to contact Elm's support or your sales managers. Eager to see you in our next training session.